Okay, shall I now? Shall I? Okay, now listen to me. Let us include the pulley now. If I include the pulley and then write the heading, when pulley is at rest, write the second subheading, that is what? When pulley is at rest or fixed. When pulley is what? Fixed. Okay, now listen to me. As we all know pulley system, why? Because we have already learned in constraint. Consider here is a fixed pulley like this. A fixed pulley, and on this fixed pulley two masses are being attached like this. This is your mass 1 and this is your mass 2. Okay, you want values? Okay, let's say this one is 2 kg and let's say this one is 3 kg. Okay, two masses on a fixed pulley which is been hanged. Okay, now we already know that this pulley is massless. First thing, this pulley is what? Massless. This string is also massless. Massless string and massless pulley. Second thing, pulley is frictionless. So the second property of this pulley is what? Frictionless. Okay, pulley is massless, frictionless, string is what? Massless. If a string is massless, we already know the basic properties of the string. That means tension at all the point remains what? Same. Now let us try to understand. Okay, so this is 3 kg, mg will be acting in the downward direction. Let's say mg on this is acting in the downward direction and having a value that is what? 30 Newton. Yes or no? Similarly, this is your 2 kg. mg will be acting again in the downward direction and this mg will be 20 Newton. Yes? This is the point of contact. This is the point of contact. Tension will be acting in the upward direction, let's say T. And this is the point of contact. Again, the tension will be acting in the upward direction, let's say T. Why we are mentioning again T and T? Why? Because it is a massless string. Okay, now, if I want to write the equation, then I have to consider the direction of acceleration. Yes or no? If I take the direction in the upward direction, I will be getting a positive value, or either I will be taking the downward direction as the acceleration, I will be getting a positive. If I am getting a negative sign, that means what I chose the direction is wrong, na? Yes or no? Over here, negative acceleration doesn't mean what? Retardation. Okay, there is no retardation or no de-acceleration here. So, now, on 3 kg, let us write the 3 kg and let us select the direction of acceleration. Let's say I am considering the body is moving in the downward direction with acceleration A. Now, from pulley constraint, again we know that if one body is going in the downward direction, the other obviously will be moving in the upward direction. This is happening. Why? Because the pulley is what? Fixed. If the pulley is in motion, maybe we need to apply the different equation. Yes or no? AP is equals to AA plus AB by 2. Yes or no? Now the pulley is fixed. At this point, pulley is fixed now. If I want to write the FBD on this one, on this 3 kg, then can I write like this? This is your 3 kg. 30 Newton is acting in the downward direction, tension is acting in the upward direction, body is accelerating in the downward direction. For that, who will be greater? 30 Newton or T? 30 Newton. So, can I say for this one, 30 minus of T, which is equals to 3A, equation number 1. Okay. Second thing, let us try to write the equation of second kg, that is my 2 kg mass. Okay. So 2 kg, this is your 2 kg and 20 Newton is acting in the downward direction, tension is acting in the upward direction, body is accelerating in the upward direction. Yes or no? Who will be greater here, T or 20? T. So if I want to write the equation over here, then T minus of 20, which is equals to 2A. This is your equation number 2. Okay. Now again this method remains same. Adding equation 1 and 2, if I add the equation 1 and 2, that means that is 30 minus of T is equals to 3A and T minus of 20, which is equals to 2A. Can I cancel this T and T? Okay. Now, I will be getting about 30 minus of 20, that is what you are 10, which is equals to 5A, or acceleration is 2 meter per square second. Yes or no? Substituting the value of acceleration in any equation, I will be getting what? Tension. So, let's say substituting here. So 30 minus of T, which is equals to 3 into how much? 2, or 30 or T is equals to 30 minus of 6, that is what, 24 Newton. Either substitute in equation 1 or either substitute in equation 2, you will be getting tension is equals to how much? 24 Newton only. Okay, this is your part 1. Now, A iron array. All we need to select what? Direction of acceleration, substituting the equation. Second thing, I can do the answer or I can calculate the acceleration by considering this as a whole system. Okay, don't try to apply that on moving pulley. Always, if the pulley is fixed, think about this one. How? Then if I consider this as a system, how many bodies are there? 2 bodies. Okay, take these 2 bodies in the horizontal direction. Consider both bodies are moving in what? Horizontal direction. So this is your method 2, and consider this is your 2 kg, this is your 3 kg. On 3 kg, what is the force mg is acting? That is what, 30 Newton. Na? So in this direction, 30 Newton is acting, and in this direction, 20 Newton is acting. Are yes or no? Okay. The second thing, pointing the tension. So at this point, tension is in this direction, and at this point, tension is in that direction. Tension is same. Why? Because string is massless. Okay. Now, writing the equation for this. This is your bigger force, 30 Newton. So 30 Newton is acting in this direction, 20 Newton is acting in that direction. So can I say 30 minus of 20, which is equals to mass. Now the mass will be 5 kg. Yes, very good. So 5 of A, or 10 by 5, which is equals to A, then acceleration will be 2 meter per square second. Either with this or either with that. Okay, your wish. Then second thing, and one more thing, remember, please don't try to apply directly on what? When the pulley is in motion. Why? You will understand in the next part. Okay. Now, acceleration is done. Now, can I also say that they can ask you to calculate the tension along this string? It is possible now. If they are asking the tension at this point, they can also ask you what will be the value of tension on this point, on this string. Let's say, if I want to see from here, then tension will be in the upward direction, let's say T dash. Okay, T1, T dash, whatever you want to take, you can take. Okay, now that pulley is massless or having some mass? Massless. If the pulley is what? Massless, then let us try to understand that also. Here is your pulley. At this point and at this point, where is the direction of tension? In the downward direction, na? At this point I am talking. At this point and at this point, what will be the direction of tension? In the downward direction. Why? Because tension always acts away from the point of contact. So, in that, over here, T is acting. Are yes or no? At this point also, T is acting in the downward direction. Now, at this point, where is the direction of tension? Upward. So, let's say T dash is acting in the upward direction. Okay. This pulley is what? Massless. That means mass of pulley is how much? 0. Applying equation 2. That means Newton's law of motion. So, if I apply second law of motion on this one, then can I write T dash minus of 2T? T dash minus of 2T. Let's say this one is accelerating in the upward direction. Okay, then T dash minus of 2T. If I say accelerating in the downward direction, obviously I would be writing what? 2T minus of T dash. Okay, either take in the upward direction or either take in the downward direction. Nothing will be happening. Okay, either the pulley is fixed or either the pulley is accelerating. Whatever the value is, this one is applicable. Now, T dash minus of 2T, which is equals to mass of pulley into acceleration. Can I say mass of pulley is 0? Are yes or no? If mass of pulley is 0, means this whole becomes what? 0. Then can I say that T dash is nothing but 2T? T dash is nothing but 2T. Now, for example, I got the equation like this one. Over here tension is 10. Over here this is the tension 10. Obviously yes. Yes or no? Massless. Okay. So tension at this string will be 20. If I say over here is 2T, over here is 2T, then over here will be 4T. Yes or no? Either the pulley is at rest or either the pulley is in motion. Always remains where the pulley is being hanged. On that string, tension will be twice. I got my point. But condition, it should be massless. If the pulley is having mass 0, then and then only this one is applicable. Okay, if pulley is having some mass, then this one is not applicable. I got my point? I know. Okay, shall I? Now I will put the question, try the answer. Okay, example number 2, 1, whatever it may be. Now consider, here is a fixed pulley again. On this fixed pulley there is a mass, and here is the mass, that is what, your 5 kg. Okay, and one person is holding this one like this. Okay, so only one mass this time. Pulley is again fixed, and this person is applying a force of 100 Newton in the downward direction. Okay, question is, find T and A of block on A. Let's say this is your A. Okay, find tension and acceleration on 5 kg mass. Come on. Yes, tension is 100. Yes, correct. Without calculating, we can say tension is 100. Why? Because this man is applying how much force, beta? 100 Newton. 100 Newton is what? The force which is acting on this string. That means still from here to here, tension remains what? 100 only now. Are yes or no? At this point, tension is acting in which direction? Can I say in the upward direction? If tension is acting in the upward direction, this is your T. Okay, and the value will remain again 100 only. Are yes or no? Okay, and this one is applying a mass, that is what, having a mass 5 kg. Obviously in the downward direction, how much? 50 Newton. Okay, who is greater, T or 50? T is greater. Obviously the acceleration is in the upward direction. Then the equation can be written as what? T minus of 50, which is equals to 5A. Are yes or no? Or T is what? 50 already done. That is what? 100 minus of 50 divided by 5. That is your acceleration. That is nothing but 10 meter per square second. Okay. कैसे आया? अच्छा चलो ऐसे पकड़ के चलो. He is applying force 100 Newton ना. Okay. Let's say. So this is your pulley, and this one is having a mass how much? 5 kg, and one more mass we don't know. One more mass we don't know. But what is the mass of the string? 0. So this is your 0 kg. Are yes or no? On 0 kg, how much is the force in which direction? In the downward direction, how much is the force? 100 Newton is acting in the downward direction. Are yes or no? If 100 Newton is acting in the downward direction, then can I say tension will be acting in the upward direction? Yes or no? Write the equation for this one. Let's say acceleration is in the downward direction. Write the equation. Who is greater here? 100 will be greater. 100 minus of T, which is equals to Ma. 100 minus of T, which is equals to what? Ma. Mass is 0. Mass is what? 0. Obviously tension is what? 100 Newton. Aya? Okay. Whenever there is no mass, obviously that force is nothing but the tension in the string. I got my point? Okay. I know. Okay. Shall I? Example number 3. Jaldi karo beta. Example number 3, and here is the surface like this, and on this surface here is the fixed pulley. On this fixed pulley, two masses are being like this. This one is one mass 30 kg, and one mass is being connected like this. This one is, let's say, 20 kg, and over here force is acting in this direction, let's say 50 Newton. Okay. Find the acceleration and tension. Again, question is find tension and acceleration. Okay, anything or no need? Come on, calculate. Okay, shall I? Everyone got the answer? Chalo, check karte hain. So this one is acting in the downward direction. That is what? 300 Newton. That is mg. Yes or no? And tension is acting in the upward direction. Acceleration kidhar lo? Niche. Okay. So acceleration in the downward direction. If I want to write the equation of 30 kg, then for 30 kg I am writing the equation, that is what? 300 minus of T, which is equals to 30A. This is your equation number 1. Yes or no? On that, over here tension will be acting in this direction. Yes or no? Okay. So acceleration, if that one is going in the downward direction, obviously this one will be going in this direction with a same acceleration. Why? Because pulley is again fixed. Who is greater, T or 50? T. So T minus of 50, which is equals to 20A. This is your equation number 2. Adding equation 1 and 2, TT get cancelled. So can I say directly लिख दो 30 minus of that 50. लिखो रे भाई, ऐसा लिखो. Adding equation 1 and 2, 30 minus of T, which is equals to 30A. Second equation is T minus of 50 is equals to 20A. Okay, can I cancel this T and T? So 50 minus, 300 minus of 50, that is what, 250, which is equals to 50A, or A is equals to 5 meter per square second. Those who have got this answer, excellent, very good. Okay, now substituting acceleration in any equation, I will be getting what? Tension. Substitute in this equation only, second equation. So T minus of 50, which is equals to 20 into 5. Are yes or no? Then 20 into 5, that is what, 100. 100 and that 50 goes over there. That means tension is equals to 150 Newton. How many of got these answers? Chalo, very good. Sabka aaya. Okay, one more. Come on, try this. Okay, shall I example number 4? Try this and consider situation is given like this. This one is theta is equals to 37 degree and here is one pulley attached like this. On this pulley, 2 masses are there. Okay, and 37 तो ये 10 ले लो. This one is 10 kg and this one is your 5 kg. Okay, question is find. No need beta. If you want to apply the force in this direction, you can apply. If you want to apply the force in this direction, your wish. And if you don't want to apply the force in any direction, your wish. It depends. All you need to apply, how to apply this F net, na? F net is equals to ma. Take the direction of acceleration, substitute that. If there is no force, that means that force becomes 0, obviously. Okay, so depends on the situation, what the question is given. Okay, find tension and acceleration. Okay, come on. Okay, shall I? Why I am saying your answer is wrong? First thing, you have taken only 100 Newton now. Now listen to me. Those who have done like this, obviously yes, mg is acting in the downward direction and that mg is equals to 100 Newton. That is true. Okay, you are not going to get the answer with 100 Newton. Okay, tension ke opposite कौन है रे force? You need to get the component of this one na. So if this one is 100, if this one is 37, then can I say that this one is nothing but mg cos of 53? और या फिर उसको लिख लो mg sin of 37, your wish. Either you write this as sin of 37 degree, your wish. Okay, now if this one is the what 100 of sin 37, that means can I say 60 Newton is acting in this direction? Yes or no? Now this you need to calculate, take this force. Okay, 60 Newton is acting on this. Tension will be acting in the opposite direction here like this. Okay, if I consider acceleration is in the downward direction, then who is greater? 60 Newton is greater. So for 60 minus of t, which is equals to 10a. This is your equation number 1. यहाँ पे 100 नहीं आएगा. That is the reason I said your answer is wrong. Okay, now अभी समझ में आया? Now listen to me. 5 kg. On this 5 kg, can I say tension is acting in this direction? Is there any force acting here? No. If force is given, consider that. If force is not given, you have to take that as 0. So acceleration is in this direction. So can I say that t minus of 0 is equals to ma? Yes or no? In this direction, how much is the force? 0 now. Or directly t is equals to how much? 5 of a. This is your equation number 2. Adding equation 1 and 2. Simple. T get cancelled. Left out is what? 60 is equals to 15a, or a is equals to 4 meter per square second. Substituting the acceleration in any equation, I will be getting what? Tension. So T is equals to 5 into 4. That is what? 20 newtons. I got my point. This is how we can do the answer. Okay? Right. Okay. Next example, example number 5. Okay? And this one will be the last example on fixed pulley. Okay, then now we will be next moving to what? Moving pulley. Okay, consider the situation is given like this, and here is a triangle, and on this triangle this is your 37, this is your 53 degrees, and here is the pulley. On this pulley one mass is connected like this, and over here also one more mass is being connected. Let's say this one is 10 kg and this one is also 10 kg. Both masses are equal. Both masses are equal. Your wish, you can take the acceleration here or either here. Anyone will be getting a negative acceleration. Negative acceleration means what you have chose the direction is wrong. Okay. Question is again, find tension and acceleration. Find T and A. Come on, again easy, but apply what? Don't apply this mg and mg. Take the component of this mg. Okay na? Come on. Okay, shall I? Everyone got the answer na? Easy hai, pata hai. Okay. So mg is acting in the downward direction, and that is nothing but your 100 Newton, and this is also mg, and over here is also 100 Newton. Are yes or no? Okay. And over here is nothing but mg sine of 53 degree, that is nothing but 100 into 4 by 5. Are yes or no? Okay. Over here that means your value is 80 Newton, and over here this is nothing but mg sine of 37. Yes or no? Mg sine of 37, and this becomes what? 100 into 3 by 5, that is what? 60 Newton. I got my point? Okay, so 60 Newton is acting in this direction, 80 Newton is acting in that direction. Can I say acceleration is in this direction, T will be over here, T will be over here, this one will be going in this direction. Are yes or no? Okay, for 10 kg, this 10 kg. For this 10 kg, I am writing the equation here. Who is greater? 80 Newton or T? 80. So 80 minus of T is equals to 10A, equation number 1. Second equation, who is greater? T will be greater. Yes. So T minus of 60 is equals to again 10A, equation number 2. Adding equation 1 and 2, T get cancelled. Okay. Either you can consider by system method or by this. Your wish. I am not forcing you to do with this only. Okay. When the pulley is at rest, you can do with anything. Okay. Now 60, 80, 20, which is equals to 20A, or acceleration is equals to 1 square meter. Substituting the value of acceleration in any equation, I will be getting what? Tension. So let us substitute in equation number 1 or 2, whatever it may be. So substituting T minus of 60 is equals to 10 into 1. Okay. And this becomes what? T is equals to 70 Newton. Are you okay now? Right on.